1957, the Soviet Union beat us into space by launching a satellite known as Sputnik. And that was a wake-up call that caused the United States to boost our investment in innovation, particularly in math and science. 50 years later, our generation's Sputnik moment is back. This is our moment.
Science is for women. Science is exciting. You can be as passionate and in love with science as you can be about literature or art.
The show has inspired me in a lot of ways.
Engineering's fun. I mean, it's so much fun. You get so much satisfaction out of making something and seeing it work.
I know I'm a better teacher now that we have the Design Squad online curriculum that's based on the activities they see on the show.
Wow, that's great. This is the first time I've seen that as we've been preparing it. So thrilled to be with you this morning. Good morning and welcome. I'm John Abbott, President and CEO here at WGBH, and we are absolutely thrilled with anticipation that you are here with us today at GBH to kick off this exciting next-generation collaboration in STEM education, bringing the universe to America's classrooms. We're both honored and grateful to be among the organizations selected by NASA to receive this generous and important award. And the grant represents and demonstrates NASA's recognition of WGBH's innovative leadership in STEM education, some elements and evidence of which you saw there, as well as our role as a leading producer and distributor of STEM content for the public media system. On behalf of our team, I want to express my sincere thanks to our colleagues at NASA for being such gracious collaborators and generous supporters of our work. We're eager to partner with you once again as we embark on this journey to the next frontier in STEM learning. WGBH has a long history of advancing STEM education in classrooms and homes across the country, as science and education are actually embedded in our DNA. Much of our STEM content and our connections with teachers and learners are linked with WGBH productions that are household names. From NOVA, the video resource widely used in America's middle and high school science classes, to Curious George, our popular children's series which introduces preschoolers to science. But our involvement goes far beyond broadcast. 4 years ago, WGBH and PBS teamed up to launch PBS LearningMedia, our online service for educators that provides access to free, classroom-ready, supplemental digital curriculum resources. This service grew out of WGBH's pioneering digital online library for K-12 educators, Teachers Domain. And I'm especially proud that WGBH took the lead in creating the site's critical STEM content. When we were planning the launch of PBS LearningMedia, we focused our attention on where we could lead, where with attention and energy we could move the ball with what was planned for PBS LearningMedia, and it was STEM that we chose. Today, PBS LearningMedia has more than 1.8 million registered teachers, students, and parents using the site's videos, images, articles, and interactive tools to enhance the learning experience. And we have partner institutions, our stations, more than 170 public television stations across this country, in every community of this country, as our partners, working with our teachers, enhancing the engagement with science in their communities, and the role of science in the classroom through these new resources, because we are the last locally owned and operated media in this country, community-based public media with boots on the ground, as we like to say, partners with teachers in every state of the nation. WGBH believes passionately in digital media's power to advance STEM education and to transform the way teachers and students learn and engage with their universe. And that passion aligns with NASA's goal to strengthen students' interest in science, technology, engineering, and math, allowing our young people to imagine a future where they can be the next generation of leaders and innovators, and perhaps astronauts. Reaching traditionally underserved student populations is another NASA priority that aligns well with our mission in public media. Digital media is a particularly powerful medium to engage underserved students, including English language learners. My friend Pat Tutwiler is here, having come from his experience leading Brighton High School, where 40% of his students were English language learners, and students also with special needs. Brian Gould from WGBH's Carl and Ruth Shapiro National Center for Accessible Media, NCAM, will say more about that later this morning with you. Today, we take our first step toward bringing to life our proposal to develop a cohesive K-12 STEM learning ecosystem of digital resources infused with NASA content for the PBS Learning platform. This is a unique opportunity to utilize NASA's amazing library of multimedia resources, including images and videos and real-time data, and to make it accessible to America's teachers and students. And that's why this collaboration is so exciting for me. The extraordinary library of resources from purpose-built institutions like NASA with that highway into these classrooms through the trusted resource of PBS LearningMedia in every community of this country. That connection, that last mile connection, so that these extraordinary library of resources have actually an easier way of connecting to the lives, the daily lives of the teachers that we're expecting to inspire our students. The extraordinary scope of this project allows us to partner with the Center for Research on Lifelong STEM Learning at Oregon State University, led by Center Director Martin Storkstieg, and partnering with Harvard University's Worldwide Telescope Ambassadors Program. We will be able to leverage the Worldwide Telescope technology to enable a personal computer to function as a virtual telescope to teach STEM concepts in school and beyond. We are overjoyed at that prospect. And our WGBH team will design, develop, and integrate this concept and content into our PBS LearningMedia for K-12 students. And later this morning, we'll hear from Elisa Goodman, the Robert Wheeler Wilson Professor of Applied Astronomy at Harvard University and Research Associate of the Smithsonian Institute, who will lead Harvard's contributions to our project. I'm very excited that WGBH is able to undertake this project, and I'd like to acknowledge our talented team who's brought us to this day. First, Rachel Connolly, Director of STEM Research at WGBH. Rachel is our STEM guru who conceptualized this program and whose remarkable vision and expertise we're so fortunate to have. Rachel works alongside Pegeen Wright, Director of Digital Learning at WGBH and co-investigator on this project. Colleagues Mike Mayo and John Rubin are among the team who are making this project a reality, and they all work under the guidance of Terry Fitzpatrick, our Visionary Vice President for Children's Media and Education. Please join me in acknowledging their collective work. And of course, we're excited to have with us our special guest, John Grunsfeld, recently retired Associate Administrator for NASA's Science Mission Directorate and a veteran astronaut. We're looking forward to John's conversation later this morning with WGBH's Innovation Hub radio host, Kara Miller. I'm grateful that you'll also have a chance to meet Kara. It is yet another piece of evidence of how our commitment to science and innovation kind of travels throughout our editorial commitments through and through WGBH. In virtually everything we do, every part of this building, our STEM commitment lives. It's now my pleasure to introduce a key collaborator with us on this effort, Kristen Erickson, Director of Science Engagement and Partnerships at NASA's Science Mission Directorate. Kristen oversaw restructuring of science education and currently directs communications for SMD. Kristen plays a critical role in overseeing the cooperative grant awardees, and we are extraordinarily grateful for her thoughtful collaboration on our project. We are looking forward to our teamwork and to the extraordinary journey we're about to begin. Please join me in welcoming Kristen Erickson.
Thank you so much, John. Looking forward to this. Well, I'm thrilled to be here today. It's been quite the journey for us, and I know was the product of a lot of hard work by the WGBH team, but on behalf of my colleague who's here with me today, Mary Sladek, and the rest of the NASA collective, what we call the collective, this is truly the beginning of a wonderful partnership that may last indeed 10 years. Now, while this session today is a kickoff meeting, but for us it's really a vitality check of a resurrected organism. So let me explain what I mean by that. Back in 2013, all of the NASA science education budgets were removed. We lost $42 million like that. Now, this is after 23 years of a practice of devoting at least 1% of our missions, like the Hubble Space Telescope or the Mars rovers, to education and public outreach. But when that money was removed by this administration, NASA Science, led by Dr. John Grunsfeld, got together and asked the right questions. Let's first think about why is NASA even in the education game? Why does NASA Science, what does NASA Science bring to the equation? And how much can we truly affect education in this country? We had $42 million that was taken away, but that was really only about a portion of this over $600 billion in the 2014 school year that was being invested in this country for public education alone. So $42 million, while it was a lot of money to us, was a drop in the bucket with regard to the investment this country makes annually. So what could we really bring to the equation? We also worked with the administration to find out why those funds were taken in the first place, and it turns out NASA Science had significant gaps. We took all of these inputs and developed a restructured NASA science education model. That resulted in a competitive solicitation that was issued about a year ago, and 27 selections were made last September, in which WGBH is a major part of. We also have many of our other partners of the 27 online that are listening right now, as well as some in the audience today, with the Earth Science component represented by Teresa Schwerin as a principal investigator, and our astrophysics component represented by the great Dr. Denise Smith from the Space Telescope Institute. But once those awards were made last September, concurrently we also got partial funding restored, so the organism had lifeblood once again. You, along with other parts of NASA, will help NASA Science Education obtain our overall goal of enabling our science experts and our content into the learning environment more effectively and efficiently for learners of all ages. Now, that is our overall desired outcome, and it's quite daunting when you think about it. It's not just one segment of the population, it's learners of all ages, and how can we infuse our content and our experts more efficiently and effectively? And that's when we recognize that NASA can't do it alone. We can only do it together. And you all are now a part of all of those, of that tremendous desired outcome. So today's session will begin a process to help answer for us what kind of NASA content do educators like yourselves and learners need. What is shown up on the screen is a representation of the 27, what we call the collective of not only the institutions but the co-investigator institutions. So you can see at a glance that while we're making great strides, there's a lot of gaps in the country that we have more work to do. This was also part of what the administration recognized. Not only was there duplication of effort, there was fragmentation, there was also major gaps regionally as well as in the science content that we were addressing. We also had a wake-up call with how we address underserved areas. So I look forward to hearing from some of the speakers later today so that we can learn better how to address those gaps. Another aspect that I would like to address today is that you are all now part of the most exciting times ever in NASA science. Just in the next 18 months, robotic explorers and the humans that drive them will reach Jupiter this July 4th. That had been a 6-year journey that the Juno spacecraft launched from the Kennedy Space Center in Florida 6 years ago. It will now arrive at Jupiter on July 4th. The Juno spacecraft has an imager, and that instrument will be taking pictures in a similar polar orbit at Jupiter that the Cassini spacecraft at Saturn, which has been there for a half a season or 15 years now, that Cassini will be taking the same images at Saturn that Jupiter will be taking at Jupiter at the same time, so the two gas giants. Now, when you think about the planning that would have happened really 20 years ago to enable this, it's really daunting. And this is the team that you're now a part of, are these really smart people that think about today as well as in the future. So those images that we're going to get from Saturn, if you can imagine, you've seen the beautiful images of Saturn over the last years, but the ones that are upcoming will be between the planet and the innermost ring in a polar orbit. It's going to be spectacular. Another mission that is launching this September 8th, no earlier than September 8th, is the OSIRIS-REx mission. And this is going to an asteroid called Bennu, and it's going to bring back a sample. Imagine getting a sample from an asteroid, and that is what is going to start in September. It's going to scoop that sample up and then return it back to Earth. On August 21st, 2017, a major date in this continent. So for the first time in 38 years, and certainly for the entirety of the continent, there will be a total solar eclipse. All North Americans will be able to participate in this eclipse led by the NASA science team. It's going to be spectacular, and we can plan on it. There's not going to be any launch delays on that one. We know it's going to be August 21st, 2017. So we have one school year to prepare, if you will. And let's not forget that the James Webb Telescope, what some have called Hubble on steroids, will be launching in 2018. These are new events in addition to the Earth scientists that continue to measure the changes of our home planet and all of our robotic assets on Mars that report the data back in support of humans getting to Mars in the 2030s. Now, all of the data that we collect and all of our products and educational materials are available free online for anyone's use. So this is something that we have in common. I would like to take a moment to address one of the obvious aspects of that online access, but obvious only when you truly take the time to think about the implications and the possibilities. Please don't get me wrong, online resources are no substitute for that personal connection, especially when that person resembles the audience that we're trying to reach. But in lieu of that, having all of our materials available for anyone enables and arguably takes out of the equation any biases that could occur otherwise. In other words, online does not prejudge who gets to play. Yes, there are still some barriers to entry, and this administration's broadband initiatives are trying to minimize those. But once online, any learner has access to the totality of NASA knowledge. Something enabling a concept called STEM equity, and this is precisely the nexus that WGBH and NASA have. So what else does NASA bring to the equation? A full spectrum of opportunities. First, by the very nature of doing the seemingly impossible in the extreme, unforgiving environment of air and space, we inspire smart kids to take those hard courses. For my generation and older, the Apollo program inspired. Now we see the Mars rover Curiosity landing inspired a whole new generation of what's a whole new generation. And what's exciting for us is that these kids, we call the Mars generation, are the ones that will actually be the generation to first set foot on Mars in the 2030s. And through NASA and now WGBH, they are embarking on their own personal journeys that may end at Mars and beyond. So in conclusion, what are the attributes? What are the attributes that help learners to become STEM leaders? Certainly hard work, determination, and making sacrifices. Taking advantage of NASA offerings like internships in far-off exotic places like Huntsville, Alabama. Identifying how to have the most well-rounded set of experiences, be them actual teaching in a classroom at the high school level or in informal education settings like the preeminent American Museum of Natural History, one of our partners up in New York City. What does it take? Recognizing that a bachelor's degree and teacher's certifications aren't enough, nor a master's degree. But in order to be one of the STEM leaders in this country, one needs to put in the endless hours of night school to obtain their PhD, while working full-time and raising a family, pushing themselves to continually learn about the most advanced technologies and to position their organization to find opportunities and make the most of them for the good of this country and the good of the country's learners. You may now have picked up on the fact that I am describing one of the most promising STEM leaders emerging in this country today. Dr. Rachel Conley, Director of STEM Research for WGBH. We are so lucky to have her on our team. As I mentioned to her earlier today, she's like already in my brain. I'll be thinking about, God, I need to do some research on this digital media, and I'll get an email from her saying, you may not have been aware of what we're doing at WGBH. So it's very exciting, and I think we're all grateful and lucky to have her as our leader. And together, I'm looking forward to not only the creation, but a nurturing environment for our new organism to grow and to thrive. Thank you.
Thank you, Kristen. I actually have to defend the dissertation before I get the doctor. So thank you for the promotion. It was really easy. Nick was one of my colleagues at Columbia University when we were getting our PhD, so he actually did the work and has the doctorate, so or finished it. So thank you so much for everybody for joining us here and online. I'm sort of humbled by the conversations that have brought us here for years. It seems like last night I had trouble sleeping because I was like, I've been waiting to talk about this for years now, and it just had this very I was scared, so I'm really glad. Thank you again for coming. So what I hope to sort of impart today is just a big picture vision of the project and where we are and what we're hoping and planning to do in the coming year or years. And this afternoon, we're going to sort of really dig into some of the details, but this is just a really big picture view. And we will have time for Q&A at the end today, so we really hope this is sort of conversation. But I remember when the original CAN proposal came out. And actually, I think when I first read it, you open it up and this is what you see. And I'll give it a moment because I hate to have lots of text on the slide and have people sit and read it out loud. So I'll let you take a moment to sort of read it because it has a lot. There's a lot in here to unpack. So these were the things that really popped out at me as I was reading this. The story and the science. How is the science changing, and what stories are we telling? And are we able to tell because of the evolution of the science? As a media organization, narrative and storytelling is really core to who we are. How can we impart adventure to students and children? How can we bring all of the different areas of NASA science and all of the assets and types of research it provides into sound instructional modules that can be stimulating and informative, but at the same time have learning outcomes that we can measure and know we're reaching them. What are the proven conduits we have available to us? As John Abbott started with the PBS LearningMedia and the reach we have. How can we take advantage of its capacity and functionality? So, and reach, finally, the most important and key to all of this is reach learners of all ages and diverse backgrounds. So this, to me, was sort of the challenge. What can we do? So I hope you'll agree that sort of what we've come up with and what we have the capacity to do is pretty inspiring. So if you could go to the next one. So I'm going to start with the science and move in from the science to the story, because what really is important, I think, to fundamentally accept in the recent age, and I was very lucky to come out of the planetarium community where I was a part of sort of the evolution of planetary domes into the digital age, where they became volumetric 3D immersive theaters to enable you to go into data. And I'll tell you what inspired me to go to grad school 10, whatever, I don't know how many years ago, Nick, you can tell me why, I don't remember. We started together. I was at the Hayden Planetarium while they were producing their first space show, and they had a 3D visualization of the Orion Nebula that they rendered out. And the PI who had the data, who gave it to us, who enabled us to create this simulation, we brought him into the theater and flew him through the Orion Nebula for the first time, and he'd been working on it for 10 years. And he cried. And he said, I've never seen the Orion Nebula like this in my life. And and just there, in that experience, had new insights and thoughts on some of the stellar interactions. And as someone with an astrophysics degree who has taught high school now, I just realized we're communicating and teaching in new ways. And we're also changing how science is done. So I think that connecting that digital science data is a new form of media that we need to tell new stories with is sort of the big picture goal that we're really, is one of the great missions and opportunities we have. So I'm going to say that essentially everything I just said visually is these are becoming these. And a lot of the scientists who work in this data are looking at this and querying this data for research purposes. But you'll see increasingly huge amounts of data, they're put on the internet or they're made available. But availability doesn't mean accessibility, especially in the digital age. For what does big data in the classroom really look like if it's done well and it's bridging that digital divide? And so I'm going to leave it to one of our preeminent STEM journalism programs here at GBH, Nova, to sort of highlight this story better than I could ever tell it to you. So I'm going to show you this clip.
Our planet, Earth. You may think you know it well, but a startling new picture is emerging of a world shaped by forces more dynamic and intertwined than we ever imagined, raising possibilities that defy common sense. How can sandstorms in the Sahara Desert transform the Amazon rainforest over 5,000 miles away? In the frigid ocean beneath Antarctica, how can a vast undersea waterfall 500 times bigger than Niagara Falls lead to a gigantic feeding frenzy near the equator? And how can warm water streaming past the coast of Africa trigger a weather catastrophe half a world away in the southern United States? Scientists have begun to find surprising answers to these and other profound questions, thanks to a network of satellites orbiting high above the Earth. Ever watchful, their senses extend far beyond what our eyes can see.
It's really the last bastion of human discovery. We're discovering new things every day.
What are these hidden forces that rule our world? How are the oceans, the continents, the atmosphere, and even the sun bound together? And how do they affect all living things? For the first time, we can understand how earth, fire, wind, and water join together to create the dynamic environments that shape life in all its forms.
Their interaction is what has created the environment, the diversity, the kind of life we see on Earth today.
With astonishing images created from a wealth of new information from satellites, this is our planet as never seen before. Earth from space. Right now on Nova.
Sorry, we'll stop there. So if you want to watch the rest of it, you can. We just announced and instituted our new teacher advisory team that I'm going to briefly mention later in the slides. But I want to say that every one of them received their welcome package with the DVD of that program in it. And we just thank Nova for doing it because it's been such a wonderful foundational way to show people what we mean when we say it's not just that there's a lot of new data, it's that we're telling new stories because of it. And I think that's the fundamental piece to it. So what stories do we need to be telling? And I think Kristen was very wonderful at sort of describing how this more cohesive approach, and we're working in this sort of, what are the narratives? What's the editorial strategy that helps us create a sort of a coherent approach across the lifespan about how we learn about our universe? And I'm going to leave it to the one of our project advisors who's the expert in this, Dr. Brian Reiser from Northwestern, who's going to really, help us ground this in this space. But I want to say briefly, when the new Next Generation Science Standards came out about a year and a half ago, now maybe 2 years soon, I'm sorry, about 2 years ago, what really I was overjoyed to see was that they actually used the term storylines. And they had learning progressions embedded in how they present the information across the K-12 spectrum. And I have found those so useful because it sort of helps us understand how we have narratives that lead from sunlight warms the Earth's surface to the role of the sun and how it drives our Earth systems. And I think that these are really wonderful, and I'm going to ways to sort of start with one of the things we are going to be doing in this first year, which is really developing, testing, and creating sort of a sound K-12 storyline and infrastructure for all of these stories that we can connect to the different various missions to understand how, over time, as new science comes in, it appropriately comes into and connects to the K-12 space. So this is one of the things we're really excited to do. We've already have a draft of it, and we're working carefully. I think what's really exciting is to get to sit down with NASA and say, okay, so what are you doing, and what are the areas of research you're working in? So this is one of the first sort of grounding things we're going to be starting with. So the other question is sort of what do we have that reaches across the K-12 spectrum? NASA has amazing stories that they tell and assets. We also have some wonderful instructional models and some understanding of how to tell stories and inspire children of all ages across the spectrum. GBH was one of the one thing that really attracted me to working here is that we have brands, if you will, programs, approaches that reach across the entire spectrum here, from PEEP in the early elementary years through Plum Landing, Fetch, Design Squad, Nova. And we've learned a lot. There's been a huge investment in learning how to create and make and inspire students in these ages. And we're really happy to work with all of the talent in all of these groups to say, how can we take all of those great stories and how can we take our instructional modules, bring them together? I call it a peanut butter and chocolate moment. Even though I have a nut allergy, I use it, it works. And together, bring it together, scale it, and then distribute it through PBS LearningMedia. So it's sort of like that's the three components that we're really working with here. So These are the kinds of things we already have that we have experience in leveraging that we're going to be able to use this first year to do a pretty robust needs assessment that I'm going to share with you briefly. Working with Planetary Sciences, NOVA's education department group did the Earth System Science Collection that actually leveraged the show I just showed you a clip from, the Earth from Space. So we have a lot of great things to work with, but now we have a more comprehensive long-term relationship where we can really dig in an ongoing way. So let me talk for a brief moment about sort of how this is going to be, where this is going to be built on and distributed through and our reach. So as John mentioned, PBS LearningMedia, which is in partnership with PBS, is our educational platform for public media distribution. We have 170 stations that we reach across the country who are invested in distributing, and 200 content contributors, including this year, most recently, Dr. Marie Zuber is here from MIT. MIT is a newly signed-on content contributor to PBS LearningMedia. And so we have a lot of partners we're really happy to work with. And here's why the platform is in a place where we're really ready to sort of test and expand what we can do. We have a new interactive lesson platform that enables us to design and deliver sort of encapsulated and often interactive in the sense that you can write text, you can create concept maps, there's a range of plugins. But it's this ability to create sort of packaged student and teacher experiences that we're really looking forward to designing in lockstep with the instructional models we're going to be developing. The curriculum hierarchy, which is going to be launching this summer, has been, it's sort of our information architecture for our entire catalog. And there's a brand new engineering and technology hierarchy that will be launched, and a redesigned science one that will now be precision aligned with the new next generation science standards. And I think that's another way we can develop, and that is also connected to state standards, every state standard. So it's not just national. We also have a multidimensional view of our catalog that we're able to look at because metrics and measurement and sort of getting a baseline of what we're doing is important. And then finally, this platform, because we're a public media public media is using it, was designed for media. And I think that's important because when we talk about science data being a new form of media, there's already a 3D video plugin to one that's already been used by some of our a PBS program that allows us to sort of play with VR and immersive video. We have 3D printing files we can deliver, so we can have the capacity to deliver some of these new kinds of media as they come online, and I think that's what we're interested in exploring. Next. So our reach. PBS LearningMedia has 1.8 million users, registered users, and reaches 40 million students across the country, and is growing. The growth this year has been tremendous. And if you go to the next slide, this is what I think is really important for us to say. We reach 65% of all U.S. public schools. The question here is that, and this is sort of, and I'll put it out there publicly. Sorry, picking if I do. I think one thing that I'm fascinated with as sort of a researcher hat is as media and technology accelerates and grows faster and faster and faster, how does the digital divide not expand quicker and quicker? Because I think the idea of having a platform that has accessibility built into it and a reach of this with the media can try, it has the ability to try to lessen the digital divide. And I'm really interested to see how that evolves. And we have another colleague who's going to be speaking right after me about what accessibility means in a digital age. 88% of Title I schools are on our platform, and we have a large bilingual population. We also have a lot of many languages represented by the resources in our catalog. So I just want to leave it with that in terms of the potential. It's sort of a little frightening when you see it. You're like, okay, this is the opportunity space. This is who we're trying to reach. So how are we going to reach students and people all over the country? I'm going to skip ahead to that. This is sort of a really great case study of a very small project we did this year that was highly impactful, and we want to thank one of our advisors, Dr. Pat Tutwiler. Where are you, Pat? There, yeah. We sat in your office and talked about this at the very beginning. Brighton High School is right down the street from us. They have 40% of, 44, higher, I'm sorry, students, of multilingual students, high needs populations. And if we wanted to know, how can we help them? Because if we understand how to help them, we can better understand how to help a lot of different students. It's just a start. And it was a great working relationship. Laura and myself and Anna and some of our colleagues spent a lot of time going and sitting with the teachers, going and watching the classes, trying out new types of contextualization and support materials to understand how do you bring like a clip from a show like you just saw into an instructional space in a way that kids they can use, it's accessible. So this, our urban STEM education initiative, we can now grow into a much larger initiative to learn about this on a broad scale. And so we've employed the people, our boots on the ground, so to speak. Who said that? Somebody said boots on the ground. These are our boots on the ground. We had a teacher advisory team that we put the call out for, and we had over 600 applicants for. And and thanks to our researcher, and Dr. Martin Surstick, who will probably speak to this later, we were able to create and I'll show you, because I always feel bad for Hawaii. And I'm sorry, Alaska. There is someone from Alaska, and that's my fault that it's not here. So, but we were able to sort of shape a very representative population of 50 educators that you can see are spread evenly across the grade bands, school settings, career level, and we also have Title I schools, ELL, special needs in this too as a factor. But I'm going to let you listen from one of them. They were really excited, and some of them are watching, and we want them to be a part of this. So one of our new teacher advisors sent a video of herself saying hello. So here we go.
Buenos días a todos. Me llamo Mary Claire Collins. Enseño kinder la mayoría del tiempo en español en una escuela bilingüe en Colorado. Es un honor trabajar en este proyecto. Good morning, everyone. My name is Mary Claire Collins. I teach kindergarten, mostly in Spanish, at a dual-language immersion school in Colorado. It's an honor to be working on this project. Thank you.
Mm-hmm. So she's the Colorado dot right there. But she also, and they sent, we had multiple videos. I can't show them all, but they're lovely, and they're just so excited to bring NASA into their classrooms, and we're really looking forward to working with them. They're an incredibly talented team. So what we're going to be doing with them, these are the questions that we're going to be learning over the summer or in back to school in the fall with them. We want to really understand how these assets, and when I say assets, things like the videos, data, imagery, things that are coming out of missions, what is appropriate and how can we bring them into the learning environment? And then how do we support the integration of them into sound instructional models? And then finally, how do we package and distribute them in a way that really meets the needs of teachers, what they need and what they're going to use? So this is just a little summer project here to go through. I'm kidding. The teachers are, this is their mission. And so on Wednesday night, we shared this with them. And a lot of them, and Carolyn Jacobs, there you go. Carolyn Jacobs is our lead trainer and supporter of this team, and she'll tell you she's been working with all of them, and they're fabulous. And they do not hesitate to reach out to Carolyn and talk to her all the time. And many of them are watching right now. And hi everybody, they're watching. So I didn't know, even though they should be in school. You really? I'm kidding. I was a teacher. I'm sorry. It's a habit. Okay. Let's go to the next slide. So here's our big picture goals, and these are NASA's goals too. Improving STEM instruction. How do we help teachers teach these topics? Increasing and sustaining engagement in STEM in an ongoing way throughout the lifespan towards a lifelong learning pathway. And how do we better serve groups historically underrepresented? So these are our goals. These are NASA's goals, and I am going to now introduce one of our colleagues here. We are really thrilled that one of our partners in this project is the National Center for Accessible Media at WGBH. And Brian Gould, who is here from NCAM. He's the Director of Accessible Learning and Assessment Technologies. Over the past 20 years, Brian has led research, authored guidelines, and developed training programs on how to best present images and multimedia to students who are blind and have low vision. He continues to spearhead efforts to develop standards-based methods of embedding short and extended image descriptions in digital books, online curriculum, and online high-stakes assessments. So we're really thrilled, given that so much of this data is visual, that we have a partner in accessibility and what it means to be accessible in a digital age. So, Brian?
Thank you, Rachel. I am Brian Gould from the WGBH's National Center for Accessible Media, better known as NCAM. And as you now know, if you didn't know before, WGBH is a leader in providing online educational, especially STEM content. But what you may not know is WGBH's long history and expertise in making online STEM content accessible for students with disabilities. And this goes to WGBH's, one of WGBH's core missions, which is to be inclusive and to broaden the audience. And we can go to the next slide. And this began even over 40 years ago with pioneering technologies that WGBH invented to provide closed captions on television and descriptive video service. Closed captions, of course, are for people who are deaf or hard of hearing, also used by people who are learning English, who are non-native speakers. And descriptive video service is used by people who are blind or visually impaired. WGBH invented these technologies, and they're still in wide use today. Having solved the problem of accessibility for the living room television set, WGBH and NCAM moved to new media and emerging technologies. And that's really NCAM's mission. NCAM is focused on researching and lifting the barriers imposed by new technology for people with disabilities, wherever technology is found, and we all know that's everywhere, right? It's in education, it's in employment, it's in entertainment. We can go to the next slide. WGBH and NCAM have really enjoyed a wonderful partnership with National Science Foundation. For over 20 years, NSF has funded us to do original research in making STEM education accessible, starting with the humble CD-ROM. How many people still use CD-ROMs? No? Okay. It was a lot of work, but that's what happens when you work on the bleeding edge. The first project was a math game on a CD-ROM called How the West Was Won, +3 × 4. It was a fun math game. Some of you might know it. We made it accessible for students with disabilities, and as you know, the CD-ROM went by the wayside. But then we're all happy that something called online video came along. And you're probably not surprised to find out that MIT was on the forefront of presenting a physics course online. And we made those physics videos and the entire course accessible for students who had trouble hearing or had trouble seeing. And the other great part of that project was that we created guidelines that we gave away for free so that others could make their digital educational media accessible for students with disability. And that's one of the things that we do all the time, which is create great resources and then give them away as widely as possible. If anyone has ever tried to follow the web content accessibility guidelines or other requirements for making web content or online educational resources accessible, you know that the first requirement is to make images accessible through text alternatives. That's writing a text description of an image. Now, when you're working in STEM, you know that images, like the carbon cycle, get very complicated very quickly. Imagine writing a text description that effectively and efficiently provides the information for someone who can't see that image. So NSF, for 6 years, funded NCAM to create the first research-based, authored the first research-based guidelines in creating effective and efficient image description for images. And those guidelines have been expanded and have been adopted throughout the educational publishing industry and are really an industry standard used by educational publishers and assessment companies today. Probably most perfectly aligned with the NASA project that we're going to be working on was our work with Teachers Domain. As John and Rachel both said, this is sort of a predecessor to what PBS LearningMedia is today. Teachers Domain was an online library of digital learning assets. We made some of them accessible through accessible content, but probably more exciting was that we made an accessible user interface, and through new standards that we developed, metadata standards for accessibility, we were able to create a search function so that students could look for the assets they needed, not only by the subject matter or by the grade level, but by their own individual accessibility requirements. So, for example, if they were looking for deep sea science in the middle school grade level, what would bubble up in the search results were captioned videos. Or if they had a certain mobility impairment, what would bubble up to the top were interactive games or other interactive elements that didn't require the use of a mouse if they couldn't use one. What we're really glad to see is that some of these accessibility features and this work continues have migrated onto PBS LearningMedia, and this great accessibility work continues. We can go to the next slide. So those are 4 highlighted projects that we've been working on over 20 years that sort of highlight NCAM's expertise in making STEM online education accessible. Where are we? What are we going to be doing on the WGBH NASA education team? That's a great question. We're going to be ensuring, first and foremost, that all of the materials that are produced follow the letter of the law in terms of accessibility, and that is Section 508, the Federal Accessibility Standard and Requirements. We're also going to be working with content and technology teams to ensure that the online experience for students with disabilities is comparable to the online experience of all students. And finally, we're all about learning. We'll provide an opportunity for all of the NASA project partners to learn more about accessibility and online STEM content. Our team is going to be led by Madeline Rothberg, our senior subject matter expert in science, in accessible science education, and Madeline has arrived. She just got in from the airport. I'm so glad. She'll be spending the rest of the day with us today. In addition to myself, we have Jeff Freed, who, among other things, has spent the last 20 years influencing and authoring global web accessibility standards. And the NCAM ship is captained by Donna Danielewski, who is right here, our director, who is saying, okay, boss, time's up. So I just want to close to say how proud NCAM is to be part of this project that is so closely aligned with WGBH's own mission of creating high-quality education content that's inclusive of all students, especially students with disabilities. Thank you.
Thank you so much. I think that paints a really beautiful picture of the sort of synergy that we have in this building that sometimes we aren't aware of until projects like this really bring us together and give us a chance to do things. So I want to tell you, as soon as we learned that Dr. Grunsfeld, or John Grunsfeld, the astronaut, is having flight trouble. He was flying himself here. And Kristen, I think you have, he was flying himself here, and he, in his own plane, and apparently has mechanical difficulties. So we'll not be here in person this afternoon, and I apologize. But the great thing is that we also have another amazing, wonderful person on our team, and we're really happy to partner with who can speak to the beauty of the universe and the space and how the evolution of science and the tools that are enabling us to connect with it so we have someone else here who's going to sort of carry the same message a lot that Dr. Grunsfeld or John was going to be bringing. So I'd like to introduce now one of our co-investigators, Dr. Alyssa Goodman. Dr. Goodman is professor of astronomy at Harvard University and a research associate of the Smithsonian Institution. Dr. Goodman's research and teaching interests span astronomy, data visualization, and online systems for research and education. In addition to serving as chair of the astronomy section of the 2015, sorry about that. In addition, Dr. Goodman was named Scientist of the Year by the Harvard Foundation. And as a co-investigator on this project, she will work with us and lead the effort to bring the power of the visualization program, Worldwide Telescope, that you're going to see here, to students through production of original guided tours that are aligned with curriculum, and also better help us understand how we can connect some of the amazing resources they've already developed into the PBS LearningMedia platform. So I think it's my honor to get to introduce Dr. Goodman. Thank you for coming over and giving us a tour of the universe.
Hi there. Apparently a new version of this wonderful software is available. But no, thank you. I really don't want that right now. Okay. Okay. So since John couldn't make it, maybe I'll take 3 minutes extra or so and show a little bit more of Worldwide Telescope. Okay. So the question that I thought I would address today is really about essentially what we can do in research now. So I have a group at Harvard that we call Seamless Astronomy that has to do with integrating what's traditionally a source of information for researchers, journal publications, literature, with data and media, and to make the access between all of those things fully seamless. And when I show you Worldwide Telescope, you'll see a better example of what I mean than these words that I can offer you now. But the idea is if we could bring that kind of system to education rather than just to research, what kind of impact would that have in classrooms and other learning environments? And so that's what we've been trying to do in something called the Worldwide Telescope Ambassadors Program. And some of my colleagues from that program are here. Hopefully you'll meet them during the course of the day. But we have Pat Udomperserd, who's the director of the Worldwide Telescope Ambassadors Program right there. Sitting next to her is Mary Becker, who's one of our excellent ambassadors who are volunteer experts who use the program in all kinds of settings, including classrooms. And Phil Sadler is there, who is an expert science education researcher, probably known to many of you, and he's part of our team. And Phil Rosenfield is next to Phil Sadler, and he's used Worldwide Telescope in many settings, including portable planetariums that he brings to classrooms. And so I'm not going to show you the planetarium version, but what Rachel was saying about Orion is fully true, and showing kids immersive data in these inflatable planetariums, which, by the way, Phil Sadler, sitting next to Phil, invented. Thank you, Phil. Is really an amazing experience, which I won't be able to share with you today. Okay, so this question, how does this seamless access change education? And so part of the way it changes, I love this picture because, what's she using the books for? To prop up the computer. Now, that does not mean that I don't think books are still useful for other than propping up a computer. But what it means is what we heard John Abbott and others say this morning, which is that the world has changed to the point where now everyone can have access with a decent internet connection to basically everything that we know about the universe. And astronomers have, for a very long time, put all of their information, or all of the information they can, put online publicly, and NASA is just an excellent example of that. There's data that goes even beyond the NASA resources that we can integrate with the amazing NASA resources. And this program that you keep hearing mentioned, Worldwide Telescope, is really the first time that a software project has put together all of these resources in one place in a really beautiful environment. And so let me show you what that woman could have been looking at on her laptop. She could have been looking at any of these things and many, many more things in an interactive environment, either on a desktop computer or on a tablet, using the web, using Windows, different kinds of software platforms. And I don't have time to show you all of these different modes of worldwide telescope, but just to give you some idea, if you look there, you can see planets, you can go to the surface of planets, you can add your own data, and very importantly, you can make these scripted paths through worldwide telescope. And I'm going to just show you actual worldwide telescope here for a minute. Okay. And so this is the environment, and just I'm going to do this way because it's much easier, so I'll just use an Xbox controller. So these $10 devices can actually be brought into the classrooms, and they're very popular, except that Pat there, who is in the back, our project director, can't stand them because if I press this button, you'll spin around and get really nauseous. But I won't do it, okay? So what I'm trying to show you is that this is, in fact, an interactive environment. So here we are, on the Earth, but I can move around the universe. And I'm just going to let, I didn't put sound and music in this tour. You can add sound and music, and I'll show you some of how that works in just a minute. But what we have here is a sort of slide-based presentation, but it looks like video. I could pause this at any point and go back to it being interactive. But just for fun, let's zoom out of the Earth. And I thought, all right, let's take a look at where the known exoplanets are, the planets outside the solar system. And then I realized, wait a minute, this thing was made in 2014, so oops, I better last night, go update this with all the new data, okay? So the green dots are actually exoplanets as of last night, but only ones that we know the distance to. And you can even, let's say that I was using this in a classroom, and instead of showing this tour, I wanted to show these exoplanets on the sky, and I wanted to zoom out as far as I can, and oops, not that far, and look around the sky, and I could even say, oh, I wonder what this one is, I wonder what this one is, and so you can actually, at any point, open this research window, and I bet that star doesn't have a Wikipedia page, but believe me, if it was something famous, I could look it up on Wikipedia. Instead, I'll show you that if we have a working internet connection, which I think we do, I can find all the data that's known about that particular star, okay, which apparently includes that it has an exoplanet. So anyway, then at any point, I can just go right back to the scripted path through the program. And so I will just close this window here and go ahead, and it'll just keep going with the tour that I made. And so these tours can play and be interactive in a browser now. This originally was a program that came out of Microsoft Research, and I was their astronomy collaborator. And what's happened is over the years, we've wanted to bring it to a wider and wider audience. And so there's now a fully HTML5-based platform that does the same things that you see here. And that's the version of Worldwide Telescope that we intend to use in this wonderful project in collaboration with GBH. And so here you're just seeing those exoplanets in the context of the galaxy to give people a sense of scale. And again, if I was doing this interactively and I could zoom in and out with this, you really get a sense of just how far away even the nearest stars are. But just for fun, and maybe for Maria, I thought it would be fun to land on Mars. So obviously this is all NASA data. This is all real data. And if I just go ahead here, I thought maybe it would be fun also to, I would love to let you do this, okay, but I'm going to get to have all the fun. Okay, so this is a lovely image called Many Rovers, where the mosaic has been put together, and you can see lots of rovers all at once. Don't you wish there were this many rovers, Kristen? Anyway, so the rover was obviously in different places at different times. But anyway, you can also do this with the Kinect, and you can do it in a planetarium. But let me tell you a little bit more about how Worldwide Telescope is being used. So one way that GBH has already used it is taking material from tours, and I'm sorry, but what I'm going to show you is actually from an interactive tour, and if you ask me later, maybe I'll have time, I'll show you the interactive tour. But this is a lovely video that Ari Daniel made about surveying the universe for galaxies and trying to understand the distribution of galaxies in terms of giving you the large-scale structure of the universe. So this is definitely an astrophysics-oriented video. But let me just show you the little passages.
Here's the question.
In this beautiful narrated video, this is all made in Worldwide Telescope. Okay? So it can be an interactive tool, an educational tool, an exploratory tool, a research tool, and a beautiful animation tool. This is indeed also from Worldwide Telescope. So you can do the surface of it. So what I can't do now is click and drag around on these mountains. But if I had more time, I would show you the interactive version, in which case I could click around and drag on the mountains, but I'm not going to do that. So hang on, I don't have enough fingers left. Okay. So importantly, whoops, I skipped the most important slide. Importantly, we have, as Rachel mentioned briefly, an established program called the Worldwide Telescope Ambassadors Program that's been funded, thank you, by NSF, and now by NASA, and also the Templeton Foundation. And just to give you some idea of what we do, first of all, you should just go to www.ambassadors.org to see the whole story. But just the two big projects that we have running right now, in addition to this collaboration here, are called ThinkSpace and Life in the Universe. And ThinkSpace is an effort to use Worldwide Telescope to improve the spatial thinking skills of learners, particularly in the sort of middle school age range. And it has to do with teaching moon phases and things that I, as a practicing astrophysicist, really thought were boring until I started understanding the connection between kind of human cognition and the preconceptions that Phil has written about a lot, and why it is that people don't understand moon phases and seasons. And it turns out to be a really interesting research project. So even though the content is moon phases and seasons and hopefully exoplanets, the teachers aren't interested in that because it's not in the curriculum standards, but we should talk about that later. Anyway, it's a fascinating project. And Life in the Universe, which is funded by the Templeton Foundation, is this great way to get kids to think about what finding life on other planets would really mean and how hard it would be to do that. So it's basically, for those who are familiar with the Drake equation, having them use Worldwide Telescope and a lot of other resources, including physical resources, to think about what their model of the universe is, what the universe really looks like, how many planets are there around how many stars, what would it mean to be hospitable to life, would we find this, all these really big questions. And we're doing that also right here in this neighborhood at the Jackson Man School, and that's a school that's very diverse in its population, and it's very different than the schools that we've worked with in Cambridge and in Lexington. And so we're learning a lot about, different communities and how the materials need to be tailored. So anyway, please talk with Pat and the other people who are here from the Ambassadors Program. And so if I have a couple more minutes, I'll show you a little bit about what's going on in research using new tools and new media. So this is a fake paper that some colleagues and I wrote last year on behalf of the American Astronomical Society. What I should say that's very important is that Worldwide Telescope itself has become a fully open source program, so the code is completely open source on GitHub. And when that happened, the American Astronomical Society, which is the big organization in the US of professional astronomers, but has a huge outreach component as well, decided that it would be a good idea to link the capacity that you see here, the ability to bring in data and give people this kind of immersive storytelling ability, as well as just data exploration, to the society. And so now the American Astronomical Society, with the AAS, which is easier to say, is the host of the Worldwide Telescope project. So in effect, you're also partnering with the American Astronomical Society. Anyway, they wanted to totally redo their scholarly publications to make them more valuable than just PDFs on web pages. And so we produced this semi-fake paper, fake in that we didn't publish it in a real journal, but we did publish it online, to just demonstrate these technologies. So you can Google paper of the future later, but let me just show you a couple of things in this paper. So this is all about data sharing and how to make data public. And just for reference, this is a figure where, again, I'm not going to take the time to do that, but if I click on Launch IPython, I can actually edit that figure and play with the data myself, which might be interesting in a high school curriculum. But let me skip to the Worldwide Telescope figure that's in here. So you see this. This is an image of the sky that was taken by Barnard in the early 1900s that appears in the Astrophysical Journal, and that is about a star formation region that I've studied called Ophiuchus. But if I click, sorry, I just can't see. I put my glasses somewhere else. If I click somewhere here, it says click here to see this image on the sky in your browser, and I say, yes, I trust you. So what's going to happen then is this web version of Worldwide Telescope will open, and here is this historical image on the sky in the context of all sky imagery. And if for some bizarre reason I wanted to see that, I don't know, in the context of the Planck microwave background, another lovely space mission, I could do that. Or I could, show something more relevant, which would be a map of the far infrared emission from dust as opposed to the blackness that you see from dust in the other image. And once again, I could bring up this research tool, this finder scope, and I could find out anything I wanted about that object at the level of professional astronomers to elementary learners. Anyway, there's all kinds of other stuff in that paper, but the last thing I wanted to show you is how citizen science plays into all of this. And so I know that there's interest in the long run in this project of bringing big data into the classrooms. And so I'll just show you how we do some of that now. So this is a project we did a couple of years ago where we used the output of a big citizen science project called the Milky Way Project that's part of the Zooniverse to find to study the influence of massive stars in blowing winds into the interstellar medium, into the gas between the stars. And there are these beautiful images which are accessible in Worldwide Telescope from the NASA Spitzer mission. Thank you again, NASA. And what we can do is cut out all the little regions that have been identified as bubbles or shells by citizens. And the way this works is if you look at the upper left corner, that's the interface that people get on the citizen science platform, and all they're asked to do is mark these bubbles. And then the quality of what they mark varies from what you see as A there, which are very good bubbles. Okay, those are ones that we're actually looking for, these. Okay, these are sort of and these are sort of terrible. Okay, and so what we want is to make a machine learning algorithm understand what we mean by good, and terrible. And by the way, this is showing you the expert agreement or non-agreement on what we mean by good and terrible. And so these are really, they're called bubble irregular, or non-bubble is good and terrible. Okay, so anyway, so this is what we need to quantify the probability of how sure we are that there's a bubble. And I'm not going to go into the details of how this works, but it does work. And this is the output of this algorithm using the input from citizen science to actually not only find new bubbles, but to really assign probabilities to what the citizens found, which allow us to use the data much better in our research. And just for fun, I should tell you that I should probably mention, I should thank NASA again, because we have another big project that I'm not showing you at all that is the official visualization software for the James Webb Space Telescope, and that's called GLUE. And that actually also unifies what I'm going to show you here, which is astronomy research having to do with imaging and brain science having to do with imaging. Okay, so this is brain imaging here, where citizens are asked to identify the borders between different structures in the brain, and then exactly the same kind of machine learning algorithm right down to what kind of code you're using, and the same kind of expert calibration is used. So I know that we're going to talk later about what it is that learners should know about how science is done and how big data and research are done now. And I really think that this kind of approach where human cognition is leveraged with computers rather than going all one way or all the other way is really important, and that NASA data is a huge source of information for this. Okay, so I'm probably not going to have time to show this to you, but these are maps of all of the articles on the sky, and you can use Worldwide Telescope to see where the sky has been studied, for what reason and when, and I can talk about this later. And lastly, I just want to tell you that this little process of putting images back on the sky, the way I showed you before, is now part of a project that was codenamed Old Astronomy, is now called Zombie Astronomy or Astronomy Rewind. Ask my colleagues at the Adler Planetarium, they keep changing the name. But anyway, what it will do is students are actually going to be able to participate in putting these images back on the sky, especially the ones where the coordinates can't be solved for automatically. And then high school students are going to do projects about the images that they help put back on the sky in this Citizens Project. Okay, this is my last slide, and Rachel and other people have asked me to show this to point out that 7 years ago, when we first started working on Worldwide Telescope, and I had the honor of being a scholar in residence here at WGBH for a year, we actually made an episode of Fetch with Ruff Ruffman using Worldwide Telescope. So I will show you a tiny little clip from that, and I will tell you that I learned just this morning, thank you, Carol, wherever she was, learning that, thank you, that Ruffman, our friendly animated dog, will be brought back to WGBH content. Woo! And we can do more of this. So here are these kids in my office. And this is like the big climax of the show where they're trying to solve this mystery about who is GR. So this is one of these tours, and they click on the button, and they find out oh no, they go to the Crab Nebula and there's this evil villain who later turns out to be Grandma Ruffman. Okay, so anyway, that's the end of what I wanted to show you this morning. Thanks.
I'm so glad you didn't have to fly here. Thank you, Alyssa, for your time. So I think it's hard to follow up something so inspiring and big but the next question is, so how do we bring this into the classroom in a way that we understand understand how to optimize it and what it's doing with students and so that is why we are really thrilled to have partnered with our research and evaluation partner, Dr. Martin Storstieg, and who is currently the director of the Center for Research on Lifelong Learning, on Lifelong STEM Learning. I apologize. Martin and I have known each other for a very long time, since our planetarium days, and it has been something we've been sort of looking forward to doing and talking about for years as we've watched the tools and digital things evolve, how we can work together. So prior to where he is now, he served as the director of the Board on Science Education at the National Research Council of the National Academy of Sciences. Over the years, his research has focused on science education and science learning, in particular helping to provide evidence-based advice to decision makers in policy, academia, and educational practice. In the 1990s, he was a science educator with the planetarium in Germany, where he developed shows and programs on global climate change, and he served as editor, host, and producer for a weekly environmental news broadcast. Martin also directs NRC's Roundtable on Climate Change Education. So, Martin, thank you for coming.
Thank you, Rachel. Thanks for having me here. Thanks for being here for this launch. This is exciting. And I'm extremely excited, but I can't follow on what has been presented so far now to something completely different, as Monty Python would say. A little more nerdy, a little more evaluation and researchy. That's why I don't even try to compete, and this is the only slide I have. I want to acknowledge that my colleague, Kelly Reidinger, is here. Who will be working with me as the key researcher on this project, and we have another team that will be supporting this. That said, you can also already see with this one image how misleading imagery can be when you look at my image up there. So I've aged since. Need to update that thing. So Rachel was mentioning this. This is a project for Rachel and I that's been years in the coming. We've known each other for a long time. I was a planetarium person dealing with media and education in my research and in my practice, creating planetarium shows that are immersive, linking them to what teachers do in the classroom, linking them to nature center presentations and experiences and all sorts of things, and getting my feet wet on all of this in the 90s. And then coming over here to the United States, and quickly after I came here, meeting Rachel, meeting Nick at NARST, at the National Association of Research on Science Teaching Conferences, and we've been thinking about these kinds of efforts ever since. But it came really to a big culminating moment when I served at the National Academies as the director of the Board on Science Education, and it came to us that, well, we should have new science education standards in this country. There was something like Common Core. Now maybe we should do the same thing for science. We were approached, we did it, and actually two people very much involved in this are also advisors to this project, Brian Reiser and Jake Foster. And so this is actually exciting to have these people here on the project to help us guide this. We'll get to that in a moment. But really, why, other than having conversation with Rachel, even back then, what would that mean to have these new standards that say, teach science in a different way, teach science the way that we actually believe it ought to be taught, through the practices, really looking big picture in a learning progression and being generative so it makes sense to students, that they ask real-life questions, that they get the excitement, and it's not just pearls on the strings of facts that you regurgitate in some test at the end, but something that excites you, something that is actually making you a lifelong learner. Just to bring in my long title here, and I'll explain that in a moment. And so part of that was how to bring that excitement to lots of classrooms and lots of teachers. So they're the educators who are suddenly faced with a conundrum. We've been teaching it in a certain way before, and we are good at doing that, more or less, and now we have to do it slightly differently. There's a massive project of moving the whole big ship called, what Kristen has been saying, the $600 billion industry, just slightly in a different direction. And that turns out to be really difficult, and it needs really all hands on deck. And this is one of the hands on the deck here, this project, that helps teachers use media increasingly more what students experience in their life, that they can see, that they can find. And it turns out it's not so easy to do this easily for teachers and students, making that happen. Make that accessible to teachers so that they can teach it effectively to students in such a way that students actually gain in different ways than they did before. Not just as a person who will now, in a bubble test, give the right answer at a multiple choice, but really getting the deeper sense of what's going on, the bigger stories, while getting excited about learning that, whether they'll themselves join the enterprise of science or STEM more generally, engineering, technology, mathematics, science in an individualized disciplinary way or in a comprehensive way, whether they do that as people who will be part of the labor force, of the research force, or whether they be citizens of this country who simply benefit from the wealth of cultural information that we have, from the wealth of information that we're generating and knowledge and useful knowledge that is more than just making some decision in the supermarket, but really also celebrates what we as human beings have been accomplishing in understanding the world around us and moving ourselves out of ignorance into something that is actually a belonging to a place that we know about. So this, to me, is where the lifelong learning comes in, and where the idea that we're not just doing this so that somebody can pass a test, but we're doing this so that somebody becomes, that somebody gets an identity as a learner of science, as somebody who knows and relates to science, as somebody who can ask interesting questions, as somebody who is able to think about when do I not know and who will know, where I can go to get information. So this is the broader context. And you can ask, so other than that, Rachel and I have been talking about when the NGSS process started, how can we support teachers and students, and what can PBS and WGBH do with its resources to make that happen? And this is basically the project, from my perspective, that is that project that we try to do and support, this broader process, this broader effort to switch and change science education and science learning as it is done in K-12 and beyond in this country. So with this big, broad overview, a Center for Research on Lifelong STEM Learning can be seen as a place where we just basically focus on out-of-school learning. That is not what it is. It says lifelong because we can't say the other things, life wide and life deep. When this center was started and I became the director, it was based on the idea that we know learners come from somewhere and they're going somewhere. Whether you have them for 45 minutes in your classroom, in a museum, anywhere else, whether they watch something at Nova or search on the internet, they have a history that is the past, the present, and the future, and we want to acknowledge that. They also have other options to learn, life-wide. Ecologies of learning are becoming increasingly more a place that or a concept that we are thinking about. Ecosystems, where you move seamlessly from your school environment to your after school, to your club at home, to the internet, where we realize it's learner-centered. It's not about the place where you learn, it is about the learning, no matter where it happens. And then life deep, where we realize, we never quite know what somebody really knows, because we only look like sometimes the drunk under the street lamp asked to, what are you looking for? My keys. Did you lose them here? No. Why are you looking here? Because there's light. The idea that we know what somebody knows and not knows is, frankly, in my mind, fairly naive. Because we haven't found a good way to know what you know about something. It is, in points, very shallow and you know fairly little. And in other points, it's extremely deep. I'm reminded of a study done as a foundation for research we did on amateur astronomers. That was done by my colleague Marnie Berenson at the Astronomical Society of the Pacific for her master's thesis at the time as an adult learner. And they looked at what amateur astronomers know And they used a fairly simple concept inventory that is used at the University of Maryland to test students, graduate students, postdocs, and instructors. And they found out that if you're an amateur astronomer and you're a member of an amateur astronomy club for more than 3 years, and if you do outreach, in this social corrective that's called an amateur astronomy club, you know as much or more than college instructors at the University of Maryland on that concept inventory. It works. So they know a lot about this stuff. And it's because they're amateurs and passionate about it. They may know very little about something else. And Elisa knows a lot about astronomy. I'm not sure what she doesn't know. So that's a component that we need to keep in mind when we look at these kinds of systems and what they can do. And so with that, for the nerdy last part, what are we doing? The first thing we're not doing is test kids on whether they can fill out the bubbles right on some kind of multiple choice test, number one. So our job here as a research partner, as an evaluation partner, is to be the transmission between the teachers and educators elsewhere that we hope will use this, who need to find this useful, need to find it usable, need to have a sense that they could use this, need to have a sense that it's effective before they engage with this kind of stuff in the classroom. It needs to be done in such a way that it is doable and that they want to do it. That's one transmission. We need to understand the teacher context. We need to help make it better for them, no matter how wonderful we are. Empirical research that checks our assumptions and looks at, does it really work, is always needed to optimize the process. So we're the partners in helping optimize the process. We want to understand whether the students gain from it what we think they should gain from it. So we have to double check whether, with all the good stuff we're doing, those outcomes we have in mind for students, which is a simultaneous learning of concepts that related to NASA, but also not killing them on the side of motivation, interest, identity development. We want to make sure that we find a balance, because what's the point of teaching this fascinating stuff that you've seen when the kids at the end of the day say, oh, now I'm totally bored and I hate it. That's not the point, right? So we are also the partners that look at, is it effective in those two directions? And feed that back to the team. This is a long-term collaboration. So we will be working together quite intimately in asking these questions and making sure we can answer them just in time. Now, in the first year, Rachel introduced our 50 teachers that we have selected because they represent for us the first line of attack in asking questions about initial ideas, initial concepts. They are typical. We chose them because they are typical in a sense that they represent the diversity of teacher experiences you can have in this country. They are, of course, completely atypical in that they applied for this. But we need people who are willing to do this with us, who are partnering with us in this process of understanding what will be useful for them, what will be usable to them, what will be good for their students, and does it fit in the context in which they have to teach and the students have to learn. So that's the part that we will do. We'll then, and we use the usual, but I don't want to bore you with methods that are used in this kind of stuff. They're not entirely completely inventive. We use what's actually working. We also do something else. Working with WGBH, we go at a large representative sample of STEM teachers in this country to go deep and wide in the question of what about this stuff that we are presenting here is really needed, wanted. So we have a more representative sense of the idea, what the need and the gaps are, so that we can fill them, that we can have a reasonable sense which broad direction we need to go, and that we don't get that wrong. So that's another component here that is really decisive for us, to not just work with a small group with which we can go deep, but with a large group of teachers, give us the voice back on what really matters overall in the whole country. We'll not leave it at that. We'll do a lot of analysis of existing data and existing reports. There's a lot that we've already learned about how to do this, and we don't have to reinvent the wheel. So we'll do that as well. And then as we go into the future, and teachers at the end of this year, more or less in the fall, will have their first prototype to actually test in the classroom. We'll be there to observe that. We'll be there to discuss with teachers how it worked, so we can give feedback on the first types of real enunciations of what this actually translates into real experiences in classrooms and real experiences for students. So that's the project that we are engaged in. But it also is a project that helps us probably, and NASA's investment here is really much appreciated, understand these concepts more generally. We hope to learn from this project. We'll be sharing what we learn from this project so that others can benefit from the results. This is not something we do hidden behind doors. We believe that what we learn here is for everybody, and we'll make that very sure that that happens. With that, I'll have a seat, and Rachel will introduce our fabulous advisors who will join me here to have some discussions around this project. Thank you.
Thank you so much, Martin. So we really wanted to take the time to get everybody to get to meet our project advisors, who we are all so thrilled that they've joined us and for this project. A few of them are not able to be here in attendance today, although they will be engaged with us throughout the year. But they were, a couple of them had a couple of major events with students. It's the end of the school year, and we totally understand. So I'm going to ask any and all of them who are in attendance who would like to join us on stage to do so as I introduce you. So Dr. Jake Foster is currently the Director for STEM at the Massachusetts Department of Elementary and Secondary Education. In this role, he oversees the state's science, tech, engineering, math, and computer science standards and curriculum frameworks, state-funded professional development opportunities, and support for districts. His expertise on this project will help us really bring a sense of scaling at state and district levels and how to support teachers in that. So thank you. Welcome, Jake. Pam Pelletier, who is not able to be here today, is in New York City with her students, is currently Director of Science, Engineering, and Technology at Boston Public Schools. Pam was a high school classroom teacher and department chair, professional development specialist, curriculum developer, and implementation advisor and district administrator. She's a wonderful advocate for teachers and the reality of what they're doing and what the classroom looks like, especially at the state and school and district level. Dr. Nicole Pinkard, who is also in Chicago and not able to join us because it's the last day of a program that she's leading, so she sadly wasn't able to attend in person. She is an associate professor in the College of Computing and Digital Media at DePaul University in Chicago. And Nicole has led efforts to implement one-to-one computing in urban schools, integrate digital media into core instruction, and create digital media learning opportunities outside of the formal school day. So we're really glad that she'll be joining our team as well. Next slide. So Dr. Nick Stroud is Associate Professor of Technology and Science Education at the Massachusetts College of Liberal Arts. His research interests are primarily in informal science education and pre-service preparation of science teachers. He also has a master's degree in astrophysics and was my tutor at Columbia in my galactic dynamics course. So I don't know if you remember that. Thank you, Nick. Dr. Brian Reiser is Professor of Learning Sciences at the School of Education and Social Policy at Northwestern University. Dr. Reiser is professor, I just said that, I apologize. It's twice in my invitation. He was a member of the National Research Council Committee authoring the report Taking Science to School in 2007, which provided research-based recommendations for improving K-8 science education. His research continues to examine how to make scientific practices meaningful and effective for classroom teachers and students. And he's a member of the National Research Council's Board of Science Education and served on the committee that authored the framework for K-12 science education. Thank you. Welcome, Brian. Dr. Maria Zuber is joining us. She is the Professor of Geophysics and Vice President for Research at the Massachusetts Institute of Technology. In this role, she oversees MIT's Lincoln Laboratory and over 60 research laboratories and centers on the campus. She's responsible for research integrity and compliance, as well as technology, licensing, and intellectual property. Her research bridges planetary geophysics and the technology of space-based laser and radio systems. Since 1990, she has held leadership roles associated with scientific experiments or instrumentation on 9 NASA missions, most notably serving as principal investigator of the Gravity Recovery and Interior Laboratory, or GRAIL mission. Vice President Zuber is the first woman to lead a science department at MIT and the first to lead a NASA planetary mission. In 2013, President Obama appointed her to the National Science Board. So we are honored to have her here with us today. Thank you. And finally, we would really also like to invite Alyssa Goodman, Dr. Alyssa Goodman, to join us again. And I'm sorry, I have one more advisor that I did not introduce, and I am very sorry. Dr. Pat Tutwiler, so if you could, is currently Deputy Superintendent for Lynn Public Schools. Prior to that, we got to know Pat well here at WGBH as in his role as headmaster at Brighton High School. His career in education began in 2000 at Brighton High, where he taught world history and United States history in the 9th grade academy, and began his administrative career at Boston English High School. He's an assistant headmaster in 2004 and has advanced from there to take on principalships and other leadership roles. And I think it's very important that we have somebody at the principal and school supervisory position here to help us understand how to bring those audiences in. So thank you, Dr. Tutwiler. Great. Would anybody, Martin, would you like to get started?
Okay. Well, thank you all for being here. And we have assembled you because you all present a different angle that can help us understand our own project. And we'd like to know, the first question I have for you and what burns in me is, from your professional perspective, and feel free to actually say from what angle you're answering this question, the first question. What do you see as the greatest opportunities that we have here that we shouldn't be missing with this project? It's a major investment. It goes for a long time. It has, as we've seen, enormous reach and potential more reach. One of the things I personally see is if we do it better, the teachers who go to PBS LearningMedia will be more to do, better stuff to do. But from your perspective, what is the greatest opportunity we shouldn't miss? And I think I start with the systems man, with Jake.
So from my perspective, I think we saw a lot of it in the introductory sections of this morning. Has to do with the ability to engage students in relevant data in context, help students understand kind of their place in the world and how actions by few can have impacts across the system. So the ability to visualize those interactions, to engage with the data at a level that lets you play with, hopefully, and interact with those systems has great value. I think too often school is a little too dry and about the facts, so to speak. So the ability to see that context and see the interplay of different components within these large systems has a lot of potential.
Thank you. Nick?
Yeah, so that's a great question, and it's hard to pick just one because there's so many great opportunities here, right? But I think, to me, the sort of connection, especially between, for all the NASA sort of products or assets or whatever we call them, right? From space data to geophysical data to all the rich sources of information that come out of NASA missions, all of that sort of being interwoven, as Jake was just mentioning, with sort of real-world context, right? Sort of bringing, as the title of the project suggests, really bringing the universe, not just space, but all those pieces that connect the Earth to space and everywhere in between, bring those into the classrooms and making it accessible for students. To me, that's huge because just putting the NASA logo on something, you're going to get students interested, teachers interested and engaged, but actually letting them play with it, letting them engage with it, to me is just a huge opportunity. So I think really that connection between the kind of actual data, the content, the experts at NASA, and bring it into the classrooms in a way that is accessible is huge, and it's a great opportunity.
Right.
Okay, well, picking up on that, I think what's been really important in driving the new standards and the framework that led to those standards is the research that shows what's been less effective in American classrooms, which is the idea that science is really about figuring out how the world works from our evidence. And too often, science classrooms are places where kids are learning about stuff that others have figured out. What's really exciting here is the chance to involve learners in actually working with data, in seeing where the questions are and not just where the answers are, and being a part of that process of working with the actual phenomena that underlie the science ideas, not just learning about the punchlines that others have figured out, but going back to, wait, why is that actually weird? Why is that interesting? Why is that exciting? And working through the logic of how does that actually work? That's what is interesting about science to those people that find it interesting.
Okay, so I think the real opportunity here, from the way that I see it, is using this incredible digital platform, which is going to draw students in, to help them make the connection that it all starts with doing your homework. Okay, I mean, to kids, you look at scientists, and scientists to them are like an alien species. Okay, it's oh my God, they're so smart, they know all this stuff, and all of us started just like them, and when we did our homework and we did our math, we did our physics, we did our English, and it enabled us to do many things, and so providing these students with fascinating data which will draw them in and really take advantage of their curiosity, and realizing, having them realize that they can be part of this, okay? But it all starts with you got to go back and do your homework, and there's no easy pathway to success. So to me, that I think is a great opportunity here.
Thank you.
Well, I'd love to pick up on what everyone else has said, but go back to something that Rachel said this morning about storytelling and how she was so excited to see that built in to the new agenda. And, what if your homework was to make a worldwide telescope tour, okay, about, the topic that you're researching? This isn't completely hypothetical. We've run several programs where students spend weeks in small groups actually making these things, and the kind of exposure that not only they get to the data and information, but that we get to what they're thinking is incredible when you change to that kind of environment. And there are all kinds of examples I could give you, but one of my favorites actually involves NASA data. So in Worldwide Telescope, there's a place where the Andromeda Galaxy is listed as the 3 faces of Andromeda, because I'm sorry, that was the title of the press release. Okay, so it's actually like a Spitzer image, a Chandra image, and a Hubble image mosaic together in 3 different colors. And so the students made this tour where they were trying to explain other galaxies and how far away they are and what they're made of and all this stuff. And they get to this place where they say, and at the 3 faces of Andromeda, so they call M31 or Andromeda the 3 faces of Andromeda. Like, they don't understand that's not the name of the galaxy. This is a teachable moment, okay? So the teacher, being an expert, or in our case, the ambassadors who are in the classroom, say to the kids when they put that in their issue, you know why they called that? That's not the name of the galaxy. Here's how multi-wavelength imaging works, right? And then the kids go back and change the tour to explain, like, oh, this is a false color image and this is how it works. But what the teachers have told us is that when the kids are just asked to, fill in the bubbles or make PowerPoint presentations even, about the constellations, which is what they often do in the astronomy section of a class, they don't do stuff like that. They don't put themselves out there, because they're like making a narration and they're putting their favorite music in the background. And so the ability to make the digital tools give for authoring, you see this with YouTube videos all the time, but right now, and I'll just say this right now, Worldwide Telescope, like I said, is an open source program. And so one of the things we're hoping to do with partners like GBH is build up the capabilities of the online tour authoring. Right now, you have to use a Windows computer. That's the only thing you have to use a Windows computer for, is to make your own tour. And you saw me running it on a Mac, but it needs a lot of work to be able to do that, okay? And we're very close to being able to have that done on the web. And so I'm saying this right now. Anybody who wants to help write the code to make it possible to author these things, I think I'm quite serious. I mean, it's transformative. Think about Google Docs, okay? So think about Google Docs for the sky, okay? So you can author collaboratively anything you want, students, teachers, et cetera, and then publish it the same way. And so we're very close to that being possible. And I think if that becomes possible, it changes the way people do their homework.
Yes. So a lot of exciting opportunities, and to summarize, there's not only the idea of exploring something that's still in the making or that's not entirely digested, and you can be part of the discovery process. You can make it more exciting. You can be creative and generative in that you're not just using media to see something, but to create and present what you've learned, what you've discovered, in some form that is tickling your creative component and your maybe even artistic one. So this sounds fantastic. Almost too good to be true. So let's go to what is the challenge here? So from your perspectives, again, this is a great project, and economists say if there's a $20 bill in front of you on the ground, don't bother picking it up because, frankly, microeconomics tells us that cannot possibly be there because somebody else has already picked it up. It's optimization. I've actually found 3 in my life so far. Proving microeconomics wrong, I guess, but I'm not sure. But given that, so if this is also fantastic, why isn't it here already? And is it so easy? Well, it is not. What are the challenges? What's the key challenges that we as a team, or Rachel and her team, and we then also as researchers have to focus on and be really brutally aware of as we go about implementing that? Maybe we start again with Jake from your perspective. Sure.
So I think picking up on Nick's notion of, the opportunities are so many, how do you choose one? Challenges, so many, how do you choose one too?
Well, choose 2 if you want to.
I think 2 notions that I will highlight. One is that we do need to think about that ecosystem notion that you were talking about. So proportionally, so little of the overall school curriculum and student experience, even within science, is about earth and space science per se. While it's critically important and it is an important part of the curriculum, the resources that we'll be pulling together here does not inform the entirety of a student's science experience. So the modes that we need to help teachers think about and get into and engage students with can't be isolated to just these topics. And how do we help them think about, to Brian's point, the overall experience that we're engaging students in, and how do these resources help with that effort?
Yeah, but, I think the challenges are many, but to me, the challenges are always, just opportunities that just haven't been explored yet, right? They are opportunities, right? So we could sort of flip the script there a little bit. And I think, to me, though, and it's already been mentioned a few times, sort of underserved, underrepresented populations, the sort of access that they have, whether it's physical access to media or just access to expertise, right? Having those experts in the classroom that can design, help design an interactive tour through Worldwide Telescope. Not every classroom has those experts, and so how do we recognize that? How do we build up capacity and do it in a way that's systematic and systemic? So that sort of underserved and underrepresented piece, to me, is huge, and that's going to be, again, I think a real opportunity here. And then the other piece, too, I think is sort of policy and sort of at a higher level, there's a lot of new things that, there's always new stuff in education, right? And there's new federal legislation, especially at the elementary school. Teachers are just sort of weary of change, at least they are in my neck of the woods, right? They just went through Common Core, English Language Arts, and Mathematics, and they're sort of like, we don't want too much more change. And so how do we introduce things that might be great and rich and wonderful and really good opportunities, but to classrooms that may not be that receptive to them? So I think, getting it out there in a way that, can leverage some of the already existing resources that WGBH has, and that NASA, sort of that excitement that NASA can bring, I think are, again, some opportunities there, but challenges nonetheless.
Thank you. So I want to talk about a challenge in terms of the idea of storylines. So Rachel talked about storylines in terms of how we're going to help learners build ideas systematically, coherently across years, and how we want the work we do in middle school to build on earlier work, and the work in biology to build on the work that we did in the physical science. We also need to think about any particular project, like working with images from the Mars rover or working with the Andromeda images, to be like a story that kids are building, not just hearing or being told about. And part of building a story is to figure out where the interesting puzzle actually is. You have to sell the story first. And so one of the major challenges is, well, it's really obvious to us as teachers or as scientists why these data are fascinating and why these data are so cool. It's not always obvious to students who are used to really exciting images in movies or wherever, and we kind of take a lot of things for granted. One of the critical roles of teachers is not to tell kids cool stuff, but to get kids unhappy with their current explanations for what's going on, and to get them to see that there's an actually interesting puzzle here that we need to figure out. So when I first see the image of the Mars planet, it looks kind of like a desert, and it's got rocks, and it's got stuff that looks like sand or whatever. It's like, okay, so that's like cool, but okay, so I'm done. I understand Mars, right? Okay, well, so like what makes the rocks, though? And some of those rocks are kind of smooth, I think. And we like figured out that rocks get smooth because water is running against them, or the wind is kind of chipping away. Wait, is there wind? Is there wind on Mars? Is there water? Wait, I don't see any water. What's going on? And what broke those rocks apart? How did that... Wait, I need to do some work here. And that's what good teachers do, is to help kids figure out, wait, there's something that looked like it was sort of making sense, but now I don't get it. Now that's hard for teachers to do, and it's a real challenge in constructing that. And we have to go beyond like, oh, this is definitely going to be cool to put these images in the hands of kids. It will be cool. And you know, when I was a kid in school, we didn't have these images from Mars. But I don't know what I don't know yet, and we need to work equally hard on that part of the problem.
Okay, so the challenge is, you know, there's a lot of stuff out there, and you know, teachers are just inundated with, you know, here's another thing, you know, and actually that was, you know, what was, you know, really so motivating for me to work with WGBH here, is because you know they're going to do it properly, right? So there's going to be quality there, and it's going to get out there. Okay, but once it gets to the classroom, okay, you know, we've got to trust that the teachers are going to get it. But then this material has to be arranged in a way that every kid in the class can use it, okay? Because if all that happens is that the one or two smartest kids in the class sit down and do it, and the rest of them stand in a circle around them and watch it, then we will not have succeeded, okay? And so the content is going to be fantastic, but it's got to be able to be accessible to every child in the classroom. And all of these kids are smart. You know, they have to believe that they're going to be able to use it.
I have an answer to your question, but I just have to tell Brian one 2-second story. Pat will remember this. One of the very first times we went to a classroom, Pat was just demonstrating the program, Worldwide Telescope, and she was showing Mars, and she showed the ice cap on Mars. And some kid, like, this is not us asking the right question, this is the kid. The kid says, why isn't there a polar ice cap on the other pole of Mars? And Pat and I, the two PhD astrophysicists, stare at each other and go, well, I don't know. That's a really good question. Okay, so sometimes just showing people information in new ways even gets them to ask. But anyway, my answer was sustainability and longevity, and sort of connecting what's learned from research to what actually goes into practice. So my background is as a physicist, as a professor at Harvard, not in the classroom. Okay, not in the K-12 classroom, and so what do I know about real education research? Okay, so thankfully I have my partner there, Phil Sadler, who's taught me a lot about real education research. But unfortunately, one of the things he's also taught me is that the way to go get a grant is to go do something new, learn something new, put it out there in a paper, and then go on to the next thing. Or maybe write a better paper about the same thing, and that's the way the education research community works. And so I've learned a lot about education research from him and from other people. But teachers don't get to make use of that. And part of the reason is that I've also learned in Washington that there's very few mechanisms to actually deploy something that works for long periods of time. And even the Department of Education, we spoke to them once about a different project, and they said, well, the states do things. And so you can talk to the states, and you can get a $50,000 grant, no offense, but this is not going to pervade every school in the state to really change the way they do things. And so I think what attracts me about this project, that the combination of NASA and GBH together, just like Maria said, it's going to be done right, and there's this very extensive network. And I'm hoping that if the project lasts as long as it can, that it has more of a staying power than your typical education research result that just, affects one or a handful of schools. And I don't mean to be insulting Phil's work, because he does often affect large numbers of schools, but not every school. And so what I'm really hoping is that we can work toward that, but I've seen that that's really, really hard, because the best research doesn't usually make it into widespread deployment.
Thank you. I want to stay on that side of the panel and go back with more specific questions. And one question that drives me to a degree, when I think about lifelong learning and the ecology, is the role of the scientists in this project, potentially. And we have you as a research scientist in astronomy, and now, Dr. Zuber, you represent, as the Vice President for Research, actually the scientific enterprise, so to say, of MIT, not a small little unknown university. And I heard it's far to the West Coast, but that said, as somebody who actually reports to the Vice President for Research on my university, I found it stunning that you joined this, because I'm curious about what both of yours perspective of the role of the scientists and the research enterprise is in feeding the NASA research enterprise, in feeding this project or a project of this type? Is it simply that, well, we produce our science, we dump it somewhere, and the people at WGBH will pick up whatever else is useful? Or is there a bigger responsibility that the scientific community itself, the research community itself, has in feeding projects of this type?
Absolutely. You can go first.
Oh, okay. All right. I'll start off. Give Alyssa a break here. So a motivation for me from the institutional standpoint is that it's one of our core missions to take the knowledge that we create and to make sure that everybody benefits from it. I mean, we scientists, we operate out of curiosity, and some of our scientists operate just purely out of their own curiosity about a question. Okay, but many of them operate out of curiosity of questions that have societal relevance. And people are motivated in different ways. But if you, it's what I tell my students all the time. If you discover something and you don't have the ability to convey those results, either in oral communication or written communication, then why did you even do it? Okay, if you just wanted to do it for your own personal gratification, that's one thing. But I do feel like we have responsibility to society. We are funded with public money, not solely public money, but taxpayers invest so that scientists can do their job, and they deserve to benefit from the knowledge that is created, because it is going to help their lives, and it is going to help the competitiveness in this country. And in fact, a lot of analysis has shown that that investment in research is really the only thing that you can demonstrate that actually drives competitiveness.
Yeah. So I mentioned that I was a scholar in residence here in 2008 to 2009, and about the third day I was here, Annie Valva, who used to be a colleague of many people here at WGBH and is now at Harvard-X, asked me, well, what do you think it is that the public doesn't know about science that they should know? And so I said, well, there's two things. I said, one is the way science is actually done, and then from a science substance point of view, I said, I don't think the public understands how important computer simulations are in climate change, finance, epidemiology, astrophysics. The way most science is actually carried out relies a tremendous amount on computer modeling. And if you say that to people, even today, they're like, oh, you mean like models, like 3D printing? It's like, no, that is not what, okay. So we actually wound up starting a project that's going on now at Harvard-X called Prediction X, and it's kind of the history of how humans have predicted their own future, okay? And this is a fascinating topic because it ties many things together, but what it lets us do, which get back to my original point, is tell the real truth about kind of the history of science, about old science, new science, and how scientists sort of blunder from, one place to another, and that looks interesting. And, Stuart Firestein has this fabulous talk about ignorance, to go back to what you were saying before, Brian, about science isn't about the answers, it's about the questions, it's about, how, and Martin, you said the same thing, that really it's not the bubble test, it's why are you asking this question, and why did this other person ask this other question, and what did they learn, and how do you go back and forth between Galileo, which we have another wonderful worldwide telescope tour about, just saying, oh yeah, Jupiter's interesting, let me look at Jupiter, oh, what are those dots, oh, whoa, they're moving, oh, oh, Jupiter has moved. So he didn't have a hypothesis. Okay, this whole scientific method nonsense, okay, drives me crazy, all right? It's like, yes, I think there might be moons around Jupiter. I will point a telescope at it, and I will write down my 7-step process that I will do. And this is how science is taught, and that is not how science is done. I mean, sure, you should ultimately have some kind of hypothesis you're testing, but not at the beginning. And so I think that the opportunity that scientists have in participating in something like this, of course they have the responsibility that Maria is talking about, but they also have a responsibility to tell the truth and, stop with the perpetuation of this myth that science is like some kind of cookbook and super boring.
Mm-hmm. Thank you. It certainly went way beyond what I had hoped. We will open this up to questions from you here in the audience, and as you are getting ready to formulate a question that is of great interest, I will ask one more question to our learning scientist as you formulate yours, which is the language of science, what people here might learn by engaging in original representations of data, images, simulations, and so on and so forth, is now overlaid to learning the concepts. And one of the things that struck me is, to what degree can we make it too hard? What do we have to be thinking about in order because the students may not have the visual language to deal with these things. They look at them all the time, but they haven't necessarily learned how to look at them from the perspective of learning, engagement, and making meaning from them. So what do we have to be considering as we are putting those two things together, both teaching them through media the stuff and teaching them how to learn how to use media to learn the stuff?
Right. So there's some interesting challenges there, and also some interesting strategies that people are exploring. The exciting thing about tools such as are being already being built and are part of this proposed project is we can give kids very powerful tools that are like, or maybe even the same as, the kinds of tools that scientists use. But the challenge there is that to use a tool, you need to understand a lot. And the trick is to make the tool actually a tool rather than the end in itself. We could teach kids about climate visualizations and teach them how to read particular kinds of diagrams or work particular kinds of software. That would be sort of losing the point, right? You want the visualization to be a way that kids can make sense of data and to also ask different kinds of questions like, let's compare one decade to another. And that's going to be really hard with tables of dozens of numbers. But if we had a picture and we could sort of subtract one picture from another, then I can start to see these patterns. The trick is to not make the means of learning how to operate the tool be the end in itself. And so to work with kids to get the questions to come out of them and then bring the tool in step by step so that it is a just-in-time kind of a thing. Because you don't want the tool or the vocabulary of science, all of which are things we can use to do the work, to become the end in itself. That's kind of one of the problems we've had in traditional American education, is making the tools become the ends in themselves. We test the kids on vocabulary and definitions rather than having those things be the way that kids investigate and make sense of interesting questions.
Nick, is there something you want to add to that?
No, I was just nodding my head because I was
yes.
Good ideas there. Yeah.
So we have a question there in the back. And please introduce yourself as you ask the question.
Thanks. I'm Irina Feingold. I'm a producer here with PBS LearningMedia and the Education Department. And I wanted to ask all of you a question that picks up from what you were saying about the scientific method and how we teach. I just would love to hear you talk about this balance between how can new technologies allow students to actually do science rather than just learn facts and discuss ideas, which is what we would do in a social studies class or an ELA class. As a producer of educational media and as a parent with children in school, what I feel concerned about is that science is often taught and the assessment is ELA, or the assessment is really social studies or history. And because doing science is often messy, doing science doesn't, you have standards, you've got your checklist of the facts they have to know at the end of the unit, and if you actually let them do the science, it may take longer or they may never get to the answer. And how can technology bring the truth, the actual act of discovery? Is that something we're getting closer to with these tools? And just to talk about that challenge.
Who wants to take it first? Brian.
Well, one thing I'd like to put in a plug for the new standards and the research that motivated them is it's no longer the case that the facts are the standards. That's one of the major innovations in the framework for K-12 science and the next generation science standards and the Massachusetts standards that have come out in other states that are either adopting NGSS or are building their own using the framework. The standards are always a combination of some sort of sense-making or communication with the scientific idea. So using the idea like what's inside of a cell, you won't have a test question that says, what's the name of this piece of this part of a cell? The question will be something like, how does the cell get what it needs in order to survive? Or like, why do we even have cells? Like, why bother? Right? That's a much more interesting question. And so by always pairing the scientific practices, making sense of data, making a prediction, explaining a pattern in what happened, the new standards really push on the usefulness of the knowledge rather than on just having the facts. Now, the question of what role technology can play, modern day science uses technology, whether it's visualization or it's communication of stuff we figured out or making graphs or working with patterns in data. Technology is now a very powerful tool that we can put in the hands of kids if we can set the context right and find phenomena that are interesting and worthwhile to investigate, help them figure out what's really cool and interesting and weird about those phenomena and worth digging into, and provide them some help in making sense of whatever it is that we're seeing. So technology is not an answer, it's just a piece of the puzzle that can help us implement good answers that the field and teachers are coming up with.
I'll give an example. So I was asked to go talk to a 4th grade class about the moon, okay? So I said to the teacher, okay, well, kind of what things do they have to know about the moon so I could just make sure I cover those. And the teacher basically said, all right, the moon goes around the Earth and the phases of the moon, and after that, that's kind of what they have to know, okay? And I was like, that's all? Oh my God. So, but technology can be super effective in the visualization of how the moon goes around the Earth, and so you could you knock that off in 5 minutes, and then you got 55 minutes to talk about all the wonderful things about the moon that aren't included, okay? And just to kind of take that a step further, there are parts of science that are well known. Okay, so Newton's laws in physics. If you study mechanics, those things are well known. Okay, but those are tools. Okay, for studying other aspects of science where things really aren't agreed upon yet. Okay, and so the question of you gotta you can look at things in different ways, but you can't violate the laws of nature in terms of how you evaluate them. Okay, and so there really is the opportunity there to really teach using the basic knowledge that you know versus the things that you don't know, and And I think that one of the the enabling parts of teaching children is when they understand that saying I don't know doesn't mean it's the wrong answer. Okay.
Can I pick up on a couple ideas that you mentioned? Because one of the interesting things for me too is a sort of systemic issues that I think this brings up, because as you said, learning science is messy, right? And that's great. But many teachers, I wouldn't say most, but many teachers aren't maybe comfortable going down that route. The administrators, right, those principals, vice principals, whoever, they come in the room and they're like, well, what's going on here? They're not sitting at their desks doing, this thing. So it looks different, right? But also then those teachers that we send out. So from my perspective, I work with, pre-service teachers. And so helping get those pre-service teachers to understand, what does this actually look like in the classroom, right? It doesn't, and you have to start then from a learner's perspective, right? So when they take an astronomy class, which I also happen to teach at the college I work at, they don't just sit there and lecture, right? They're actually doing things, because part of what we know is that teachers teach the way they were taught. So if they're going to be taught in undergrad science, through rote memorization, here's the list of facts, you're going to get tested at the final exam, it's cumulative, you better do well. If they learn that way and then they go into the classroom, that's the way they're going to think of science, and that's the way they're going to present it. So I think this is biting off a good chunk, but still just a chunk of this bigger kind of systemic science education puzzle that many of us, that many others continues to work on. And so I think it's it has to start somewhere, but it also has to start in lots of places, and that gets at the idea of lifelong learning too. So.
Well, another one.
We'll take one more question,
yeah.
because
Phil.
Dr. Sadler.
Is this on?
Yes, it is.
Okay. I want to pick up on what you just said, and that teachers generally teach science using the methods in which they have learned it themselves. So in that 500-student introductory physics class that I experienced at MIT, or that students now experience at Harvard, they try to recreate those riveting lectures and demonstrations that kept the students barely awake in their own classrooms. So what are the plans for professional development so that teachers can actually experience a new way of learning science using big data? What are their plans?
And that's a great question for Rachel, who just happens to stand at the podium as the most competent person to answer that. But I can tell you, before Rachel answers it, when we first met, our big idea that we had is to say, here's the NGSS coming. They're a different norm for what a classroom looks like. Can we put this norm on the web? Can we take the power of good media and the reach of something like PBS LearningMedia to change what people consider to be a good classroom to look like by taking examples that teachers can learn from, put them there, and have people see this is how it looks, not just like the instructions on how to make it happen, so that everybody else says, oh yeah, that's not the classroom where the kids sit in a row and silently fill out a worksheet. This is a messy kind of thing, and it's exciting. So, but with that's just to go from where we started at some point. What do you have in mind?
And so I think the mechanisms and the channels for reaching teachers are there. I think we've demonstrated that we have reach. We have a lot of different tools at self-paced professional development, live experience. I mean, there's a lot. But I think the question of what the support needs to be, which is really that I think is what really we're here. And I'll be dead honest here. My dissertation work was in teacher professional development and support of using data visualizations, and I got fascinated by that from an extension of seeing the dome and the experiences people were having in it. And I was teaching a pre-service teacher class at the Museum of Natural History with Lehman College, and I showed a visualization of all the wind patterns of the Earth for 1 month. Didn't even tell them what it was, just showed them the data, the satellite imagery, you see the outlines of continents, clouds. And I asked them, what do you think this is? And the first person who stood up and answered she said, well, I see now why when my family and where we lived in the Caribbean got windstorms from Africa. And someone else raised their hand and said, I understand now why Columbus didn't make it back from America. So I'm sitting here thinking, I'm going to hear clouds. And the stories they were telling floored me. And so I just went into and said, I have a dissertation question. How do we teach with these new kinds of tools? And I used four simulations. One of, the Earth's magnetic field, one of ozone, four selected ones, and gave them to teachers raw, meaning no narration, no label, and gave them to them with the fully contextualized, ready to go, the stuff we think they want to tell and do in the classroom, and watched what they did. And what fascinated me was two things. They preferred the teachers who were maybe not great at science, because there were a lot of teachers there who were, in the elementary years, who were not science teachers, but they had to teach science. They were fabulous storytellers. And this one teacher had the whole, simulation of the solar wind hitting the Earth's magnetic field. And she's like, what is it, windshield and rain. I mean, it was just beautiful. And I was like, she did it better than the high school physics teacher who had 5 masters in astrophysics, because she was this fabulous storyteller. And I think that's where I got the idea that we're teaching in new ways or telling new stories. So the answer is I don't quite know how we're going to help them with all these new tools and these stories, but I do think we have some good mechanisms for once we learn that. So this first year, one of our goals is to understand from these teachers, what they do when they test and prototype, but we're going to watch and see what kinds of support we need to be giving them. Because with that, in future years, that will help us design the professional development needed to do that. I hope that answers your question, which is no, I don't know. But we're going to find out. Thank you, Kristen.
Yes, but a thing I think that Rachel points out is that we will question our assumption. If anything, your dissertation shows that, well, what you think they may need may not necessarily be the best way to do it. And so we'll be very careful in using the evidence that we get to craft this to the needs of various types of teachers. Mm-hmm. They're not just one bunch.
I had one question in my teacher instrument that I didn't think would be really interesting, but you know how sometimes emerging, it's like, wow, this just blew up in my face and became a chapter. They don't understand simulation, animation, visualization. Those words are meaningless or differential. They use them in various, and what everybody says they mean are different. So I think, even the language we're so used to is new to them. So I'm okay. I was going to say that this is what the rest of the day is going to look like. At this point, I'd like to give a hand to all of our fabulous project advisors and say we're really happy you're here for the journey, and the tremendous capacity and expertise on this stage is amazing. So we are going to now conclude the live stream portion. Thank you, everybody who watched and stuck with us. And everybody here in attendance, I cannot thank you enough for turning out and supporting our project and that. We are now going to transition up to the project advisor afternoon session. And so everybody who is going to be in attendance to that, we will be meeting right out here in the theater, or in the atrium. We'll be bringing you up to the Connors boardroom where we will have a little bit of time and break and have lunch and move into the afternoon session. So thank you again.